Now, this first session is brought to you by Snowflake, and we'll be hearing from Michael Schafers from TUI Hotels and Resorts. The presentation is entitled Meet the Dude. We'll find out more about the dude in the presentation, I'm sure, but meet the dude, unlocking fast and accurate customer deduplication at TUI. So that gives you maybe a little hint what the dude is and what it does. And in this presentation, Michael is going to be sharing his journey to tackle the duplication of customer information at TUI and reducing that and improving and optimizing it. So as I said, don't forget to submit your questions throughout the presentation and we'll tackle those at the end. But for now, that's all from me, and I'll hand you straight over to Michael.
Thank you, James, and thank you all for joining today. And in my presentation, I will introduce you to the Dude, which is our very own approach to customer deduplication here at TUI Hotels and Resorts. But before I start my talk, let me ask you a quick question to the audience. Have you ever received the same advertising mailing twice or more? This could be electronic mailing like newsletters or printed letters that appear in the post box of your in front of your house, so that doesn't matter. And James asked me if I want to include a poll on this, but I said, no, I think that's not necessary because I know that the answer is almost 100% yes. So I think everybody should have experienced this and got the same mailing twice or more on the same day. So let's have a closer look at some examples. So the other day, I opened my mailbox and found this first letter. So looking at this, everything seems quite good. It has the name on it, the job title and the address. But then I looked further and found another letter from the same company on the same day. So here you can see that there are some minor variations in the name, and the company name is printed instead of the job title. But all in all, this still looks quite good. And then I'm looking further, and a third letter appears. Here you can see they seem to have some encoding problems with the German umlaut in my name. And guess what? There's another letter which again shows a slight variation in the name and the address. So I guess you get the idea that sometimes you have these letters that are actually the same, but they have a different address on it. And in this case, of course, it is complete nonsense to send 4 letters to one person because at the end of the day, they are all meant to address me as a person. So one letter would have been enough. And what we see here is that we have multiple representations or multiple appearances of the same real-world customer, which is me in this case. Speaking more technical, we have several database records which are represented by the name and address tags here that actually refer to the same customer entity in the real world again. And whenever we see this, there is a need for data deduplication, in our case, customer deduplication, which is the topic of my talk today. For those of you who don't know TUI, here are some key numbers for the company. So TUI is a tourism company, and in fact, it's even the largest tourism group in the world. So these are the numbers for 2019, and we have about 70,000 employees around the globe. We own approximately 400 hotels, 18 cruise ships, several planes, and so on. The most interesting number for this talk is the number in the lower right corner. TUI has a worldwide customer base of nearly 28 million customers, so that's quite some good data to work with. Today, I don't represent all of TUI. My team is called TUI Hotels and Resorts Analytics, and that's pretty much what we do. We provide analytics solutions for TUI's hotel business, mostly for the 3 major hotel brands, TUI Blue, Robinson, and TUI Magic Live. And let's have a closer look at the data that we work with in my team. So of course we have a lot of booking data. So all the reservations that arrive in the hotels, either direct bookings at the front desk. So if you call a hotel, then you can do a new reservation, or online bookings or bookings from our tour operators. Everything is held in a software we call PMS, a property management system, and we know which guest arrives at what date, at which rate, in which room, and so on. Of course, we use this data to build some management KPIs. So for example, hotel occupancy or revenue reporting. So that's what we give to the management on a higher level. But we also have very detailed data, for example, POS data. So if you order some food in the restaurant in your hotel, or have a drink at the bar, or get a spa treatment, of course, this data is collected for billing, and this goes to the PMS as well. And in the end, we can also see that data in our department. We have another team that is doing CRM and working with customer data, and some further smaller data sources like tracking applications for our websites and for our apps. And we use all this data to store it in our central analytics platform, which is based on Snowflake. And with the power of this cloud-based data warehouse, we want to have one comprehensive data source for all of our reporting needs. So we treat our central analytics platform as a single source of truth, and we don't want to have any data silos around the company, but we are the main place to collect all the data for the hotel business. And if you look at this, we know our customers quite well. So it might be a good idea to give some recommendations for our customers for the next stay. So for example, some customers have enjoyed a great spa treatment 2 years ago, and maybe we want to send them a reminder. Hey, do you remember that great massage you had in our hotel? Don't you want to come back and book again with us? And here's a special offer with a package of a hotel stay together with this massage treatment. Or we can see, for example, from the booking data that a family did some vacation for skiing in TUI Blue hotels for the last 3 years. Why don't we ask them if they want to spend their this year's ski vacation with us again? But if we look at this in detail, we can see that there might be some problems if your input data is not that clean as you want it to be. So if you look at the right columns of this example data table, you can see that for 3 consecutive years, you see that some kind of beach hotels were booked in Greece. And if we look at the left side, the second column, the customer name, for us as humans, it seems quite clear that this customer that we look at might indeed be the same customer, but for a computer, for an algorithm, it is not the case, because we see there are different customer IDs for all these 3 records. So these are all unique entities for an algorithm, and you can't see the full history for one customer because you think these are 3 different customers. And this is where we need the DUTE. The DUTE is our TUI Hotels engine for duplicate detection, and it was built by us to challenge this task of data deduplication. And on the lower side of the screen, you can see the result table after the DUTE has done its magic. And we can see that finally we can recognize this customer as one. It has just one ID now and always the same name. And with that, we can build our recommendations for that customer and maybe say for 2021, don't you want to stay in a beach hotel in Greece with us again? So the DUTE is actually based on a pretty classic approach to data matching and deduplication, which you can find in the literature and in academia. And there are basically 5 steps that we do with our data. So first we start with some data cleaning, then we generate our match candidates, then we have some similarity calculation, and finally we apply our rule-based matching. And in the end, we have a merging step that creates one comprehensive view for all the deduplicated database records. So for data cleaning, this is really the first step to make more sense of the input data and to get a common format of this. So we strip any kind of special characters. Sometimes we even strip white spaces. We ignore the case, so it does not matter if we have uppercase or lowercase spelling. And for example, we use one common format for address data. Next step is the candidate generation. And there we can't go the simple way and compare every record with all the other records. So our goal here is to identify pairs of customers that could possibly match so that they already have some kind of similarity. I will come back to this soon. Then the actual step of similarity calculation. Here we apply some similarity measures to estimate our match quality. So in the end, we have a metric that takes either strings or date values, and we end up with a numeric value that tells us these 2 strings, for example, names are about 70% similar or they are 90% similar. And based on this, we can finally do a classification and see if our match candidate is indeed a valid duplicate. And we have developed a set of threshold-based rules to look at these similarity values we have calculated before and do the classification based on this. Finally, for the merging step, we built something that we call a golden record. So this is the record with the best information quality, the most comprehensive set of information. We fill missing values with data from the other records, or we always use the latest information for address data and so on. So it is our goal to have one representation of the customer that has the best and the most up-to-date information in it. So let's take a closer look at the candidate generation and our blocking step. So as I said, the naive approach would be to build something that is called the Cartesian product, and which just means you compare every customer from your database with every other customer from your database. But if you look at the numbers on the right side, even for 1,000 customers, you end up with 1 million candidates. And for our subset of TUI's customer data, which is important for us for the hotel business, which are 5 million customers, you end up with this large number of, I think it's 25 billion or even more candidates. And if you look at the full customer database that TUI has, the number is even larger. And even if the calculation step for one single customer takes just fractions of a second, you will end up in processing times of weeks and months or maybe even years. So that is not a very good solution, and it does not scale at all. So what can we do to do better? In the literature, you find something that is called blocking techniques. And basically, that's just the application of a simple function which is cheap in computation to build some initial candidate pairs. So with the set of our customers here on our left, we apply some simple joins based on criteria that are easy to compute. For example, we check all the candidate pairs that have the same birth date, or they have the same or a very similar email address, and we build pairs of customers which are our final match candidates. On the top, you can see some function that is called soundex, which is a very old approach, which has its root in American immigration, which takes the pronunciation of words, for example, names, into account, because sometimes you have a very similar pronunciation of different spellings, and this leads to dirty data in terms of our deduplication. And so this is a good approach to have a simple comparison for names that have the same sound or the same pronunciation. With all that, we end up with a candidate set of about 300 million candidates for our 5 million customers that we have used for our initial project, which still is quite a lot, but with the modern technologies like Snowflake, this is easy to handle, and we have made very good experiences with this number, and so this works great for us. Now let's take a closer look at the similarity calculations. So our similarity measures are applied to different attributes of a given pair of possible matching customers, which are our match candidates that we just calculated in the step before. And as I said, the similarity measures are a metric to map attributes or a combination of attributes to a numeric value between 0 and 1, with 0 being the most dissimilar value and 1 meaning 100% similarity or equality. And you can find some of these measures in the literature. For example, for our string-based similarity calculation, we use something that is called the edit distance, which basically compares two strings and sums up the number of positions that need to be changed to transform one string to the other. So you have a high edit distance if your strings are completely different, and you have a low edit distance if they are the same or if they are equal. This is also known as the Liebenstein distance in the literature. And for those of you interested, I have put the formula here to turn that distance measure to a similarity measure. So we take the length of our strings, which could be the last name or the first name, and do a calculation with the edit distance, as I mentioned, and then we end up in a numeric value between 0 and 1. And we do this for all kinds of attributes that we have available in our customer data, for example, names, email addresses, post addresses, phone numbers, the date of birth, and so on. The fourth step for our DUTE algorithm is our rule-based matching, and there we check our similarity values that we calculate in the previous step and classify each match candidate as a match or as a non-match. We can apply rules like this one. If the similarity values for both name and address attributes are high, more than 90%, then we have a match. And we have a set of approximately 10 of these rules, so we can combine, for example, the name and the email address, the phone number and the birth date. So whatever seems to make sense can be combined here. And speaking more technically, you can see a representation of a rule at the bottom of the slide. So we have the similarity values that were calculated in the previous step, for example, the last name, first name, and so on. And we check if these are higher than a threshold that we set. And we define the rules together with our business users because they know best about their data quality, and then they know when customers should be matched or deduplicated. And we have built a very nice dashboard with our reporting tool, and our business users can analyze the results. So for every matching that we find, we have a very transparent view. What were the similarity values for this match candidate, which rules did apply, and so everybody knows why a classification for match or non-match happens in our case. Let's have a look on our implementation. So the Dude is implemented in 100% pure Snowflake SQL. So that's a great story because for us, Snowflake is a well-known technology and well-known platform because we use it for more than a year in our department. And for the task of deduplication, we don't have to consider buying new hardware. We don't need no operations tasks, no people caring about servers, no other tools and skills are required. And SQL is a very old industry standard, so chances are great even if a new colleague joins our team, then it's easy for her or him to understand what we did here. Second, the Snowflake SQL is a great framework for our development. So it provides already hundreds of useful inbuilt functions that we could use for our development. For example, the soundex function that I mentioned before to simplify a given string based on the pronunciation. And they even have an implementation for the edit distance. So there was no work needed for us to implement these measures, and we could start right away. A big plus as well is performance and elasticity. So data matching is quite a complex task and usually requires a lot of computing power. And with Snowflake, we have this computing power. So Snowflake offers impressive query processing, which we also noticed during our work with the Dude. And the good thing is that we can even scale the computing power. So Snowflake comes with a concept they call warehouses, where they have the computing power inside. So we started with a small-sized warehouse, and now we switched to a medium-sized warehouse, but there are still more to come. They also offer large, extra large, and so on. So if our customer base grows, there's still a lot of room for growing on the computational power. And last point on this slide, we were really able to have a quick success with this setup of Snowflake technologies. So we had our prototype ready within 1 week because we did not have to set up the hardware, the server, software. We did not need to learn a new programming language. Everything was there with SQL, and we had this framework of the inbuilt functions. And so we were up and running with the Dude within 1 week. And with the short execution times that we have, this really allows us to follow an agile approach to development. So if we change something, we can immediately see what does change in the result. We can try new things, try new rules, for example, and see how the resulting matches look like. And this is really a plus instead of having to wait for hours or days if you can see what your code changes actually do. So let me conclude my presentation with a short comparison. So before we started developing the Dude, we had a an existing solution in our department, which was developed by an external supplier. And this already is the first problem in terms of knowledge or process control. Everything was controlled by the external supplier. And for us, this process was just a black box. So even if our business users found some customers that were matched wrong, so where the process did some unwanted deduplication, they had no chance on knowing why this happens or how they could avoid these errors in the future. So this is really a plus to have everything inside. So our internal team knows the process very well. We have always did a lot of work with our business users, so they know the process, they know the system, they know the rules. And as I said, as it's standard SQL, we can really transfer the knowledge even to other colleagues or new colleagues. Second, the infrastructure requirements. The old solution required its own database server. They wanted to have their own ETL tool to load the data into their system. And of course, we had to buy the license for the deduplication tool, which was based on some data science suite. And this also, of course, cost some time to set up and manage. And for the Dude, we have almost no infrastructure requirements. Of course, we require Snowflake, but that's something we use anyways in our department. So there's no need for other infrastructure here. Now, let's look at the two last points, which are actually the best. So for the previous resolution, we had a very, very long runtime. So a complete matching for the whole customer database was always an overnight run. And if the process failed overnight, you had to wait quite some hours until you had your another result. And with the Dude, we managed to get this down to a 10-minute task, which is really impressive for the amount of data that we consider, for the number of match candidates that we generate in between, and for all the calculations that we apply. So this is really cool. And as I said before, this is on a medium-sized warehouse, and we still have more room to increase the computing power, which could lead even to lower runtimes in our case. And finally, the monthly operational cost, which were about 1,500 euros for the previous solution, which is just the operational cost like server and database licenses and the license of the deduplication tool. Of course, there has been some extra cost to set everything up, to develop the solution and so on. So we have 1,500 euros for the previous solution and less than 15 euros for our solution with the Dude. So sorry to all Snowflake sales representatives, you won't get rich with the Dude. But for us as a department, yeah, that's a great success to have this less in costs and in runtimes. So that's it for my presentation today. Thanks again, everyone, for joining today. And now I'm looking forward to your questions. James, back to you. James, I think you're muted.
Can you hear me?
Yes.
There we go. It wouldn't be an online event without somebody being on mute, right? Well, thank you for that, Michael. I thought it was a really interesting presentation, especially I think it was only a few weeks ago that I last got a duplicated marketing piece through the post. So very, very relevant in my life, I'm sure. So thank you for that. And just to remind the audience as well, we are going to do some questions. If you would like to submit them, just type into the box. You can ask. I'll volunteer him to ask You can ask anything you like, and I'm sure Michael will do his best to give an honest and truthful answer. So do get those questions in. I'm going to kick things off with a question of my own. So I actually got married a couple of years ago now, but my wife is always receiving things under a maiden name, under a new name. When we make, she does it herself. When we go to a restaurant, she'll book it under a maiden name. We have that problem all the time. So the first thing that came to my mind is, can you find duplicate records for customers who have changed their name if they've been married for any other reason? Can you still find those duplicates there?
Yes, we can find them. Of course, not all of them. But for example, if some attributes or some of their data remains the same as before the name change, which is usually their birth date, which shouldn't change, or maybe sometimes we even have, we are lucky that they still live at their same post address, or they haven't changed their email address yet. And if some of these apply, then we can find these also as duplicates. That's a huge advantage of our blocking techniques, because if you remember that slide, we have some more criteria than just the name, and with that we can find also duplicates that have a different name now.
Yeah, it makes sense. It's almost like being a detective, trying to piece these pieces together and say, oh, well, it's a different name, but all these other identifiers look the same, so you can make that that realization that it's the same person. That's great. One other question that I had actually was, how is it possible that, so you're talking about kind of reducing the runtime and how much more efficient it is under this system. Could you scale that further could you reduce the run times further by adding more Snowflake compute power? Would that be possible?
Yeah, that's definitely one advantage that we have with the Snowflake data platform. It always allows you to scale up your data warehouse, and we can do this for either a larger input set of more customers that we want to process. So if we want to process more data and have the same runtime, then this is an appropriate approach. Or we could even use this to be even faster with our existing customer database. Absolutely,
absolutely, makes sense. And then the final question that I had was, and if you have questions from the audience, do get those in, and we'll put those to Michael as well. I know sometimes it takes a little while for people to type them and word them exactly how they want, so I'll do one final question as well there. I've also put up Michael's contact details on the screen, which was just the last slide of his deck. So my last thought is, how do you evaluate the quality, the result quality, after the matching process? So you've done the matching. How do you then evaluate the result and the quality that you get out the other end?
Yeah, that's actually a very good question, because that's always a tough topic, because you don't have a reference data set. Of course, there's no deduplicated data set that you can compare your result with, because if that exists, you don't need your own algorithm. But what we do is that we have some samples that we look at. We have our business users that are trained to look at difficult cases. So, for example, they know last names that appear very often in their customer database, and where they had wrong matchings in the past. So we have built this nice dashboard where they have a good control on the results. They can see for all the results that we generate what was the reason that this particular record was classified as a match or not. And so that's how we evaluate the result quality. And we always save these findings of our business users, and now we have quite a good set for reference data. And with every change that we make to our algorithm, we compare the results to the results that we already know. So that's our way to compare or evaluate the match quality.
That makes sense. That's great. And we've had a question come through here. So let me just have a look at this one. So this one says, have you seen any positive results as far as bookings are concerned since implementing this solution? So I suppose, have you been able to link, this you were talking about the personalization and also the deduplication. Have you seen any impact, or can you measure the impact that it's had on bookings since using this system?
Yeah, actually, that's of course where we want to end. But to be honest, we don't have our solution in production for that long time, so we haven't done any evaluation in that area. But what we can say today is that there are less complaints from customers that we previously had, that they said, okay, I have this newsletter and I have 2 copies of the same newsletter, and you sent me the same printed catalog twice. And so these complaints have been reduced with the introduction of our solution, as we are taught by our business users.
Yeah, absolutely. So I suppose that's the immediate effect that you see, that once you remove that duplication, instead of having lots of people saying, why are you sending me this 3 or 4 times, you immediately see that drop off. And then, as you say, maybe it's a more long-term goal to actually follow that through and work out the impact on booking. So no, that's a great question. Thank you for that question. We've got another one here, which, again, is an understandably popular question at the moment, which is around COVID and COVID-19 and the impacts there. And I'm sure TUI obviously will have been in an industry that's been quite heavily affected by that. So this question is, how has COVID-19 impacted the way that you use data and analytics? So not just obviously, the impacts on TUI, I'm sure fairly obvious, but in terms of, has it had any impact on how you use data analytics? Have you had to set anything new up? Are you looking at it in a different way? Are you looking for different things from your data analytics because of the COVID-19 pandemic?
Of course, we have a lot of business demands these days because of the pandemic. Not that much in the area of customers that I've talked about today, but of course we have a high demand for let's say more details on the occupancy. So the hotels want to know from which countries are their customers coming, and if there are any travel regulations in that country, or we even try to link the reservations with the current COVID-19 numbers, so that we can estimate for that country that we have that amount of bookings. There are rising it's a rising number of cases, and this could possibly lead to some travel regulations. So for the hotels, it is important to know how many guests are arriving, how many guests can reach our hotel, and does it make sense to operate the hotel if there are just few guests, or can we reduce our operations to accommodate the guests that can arrive, but still not spend that much? And is there a way to decrease our operational costs?
Yeah, that makes sense. And in terms of kind of modeling that and predicting it, is it something that you've been relatively successful at trying to follow those trends of case numbers and countries' individual figures, and then plotting through, we're seeing an increase here, so we may see less customers from that country, which is affecting this? Is that something that you've been able to kind of model and build predictions and actually have actionable insights for the hotel from that?
Actually, it's not that we had some rocket science around this. We just used some trends that we could see from the last X days, and there you can quite easily see if the numbers are rising or falling. But we didn't do a detailed prediction in what numbers we can see an increase or decrease. So that was more an easy approach.
Yeah, and I suppose speed is of the essence in that kind of situations where you don't have a long time to build a very complicated machine learning algorithm, but it's easier just to, I suppose, keep things simple and take the insight from that. So yeah, that makes a lot of sense. Well, I think that's about all of the questions that we've received through. I'm sure Michael would be happy to connect with the audience. If you would like to follow up with him on any of those kind of points, then he's got the contact details on screen there, his email, and I'm sure LinkedIn. I know you're on LinkedIn as well, yes. Michael. So if you'd like to reach out further, do please get in touch. And all that really remains for me to say is thank you, Michael, for sharing the experience, and to Snowflake for sponsoring the session and enabling us to hear from Michael. So thank you.
Thank you, James.